this video, we are going to plot the signal x of t, which is given in terms of a standard signals like step and ramp. And once we plot the signal x of t, we will find out even and odd parts. So here is the signal equation. X of t equals u of t minus r of t plus r of t minus 1. For this, we need to plot x of t, and after plotting, we need to obtain even and odd part. So let's see how to plot the signal x of t. It's a addition of three signals, rather you can consider an algebraic sum of three equations. So three inputs or three standard signals are u of t. So u of t is like this. It's a unit step function, hence the magnitude is 1. Then we have r of t. It is a ramp function with a slope 1. Because nothing is mentioned over here, so magnitude is 1. Meaning slope of this line is 1. So this is how I've shown r of t. And third is r of t minus 1. It is same as the ramp, only thing is that it is shifted or delayed by 1 unit. So it will reach the value 1, which is nothing but a slope at t equal to 2. So this is r of t minus 1. So what we need to do? We need to do u of t minus r of t plus r of t minus 1. So let's see how the resultant plot will look like. From 0 to 1, the magnitude is 1 and slope is 1. So what we can see over here is at the instant when the signal will reach t equal to 1, unit step will have the value 1, ramp will also have the value 1. So if you subtract 1 minus 1, it becomes 0, and this ramp will have the value 0 at t equal to 1. So what I can say, 1 minus 1 minus 0 will give you answer 0. So t equal to 1 will get this. It has to be a 0. Slope of this line is 0 because it's a flat, whereas slope of this line is 1. So if I add the slopes, it will become slopes 0 plus 1, and over here nothing is there, so the value is also 0, slope is also 0. So 0 slope, 1 slope, 0 slope, if I add, I will get slope as 1. So slope 1, so if I subtract these two slopes, I will get slope as 0 minus 1, which is nothing but minus 1, and this minus 1 I need to add with this 0. So in the end, the slope of the line I will get minus 1 from 0 to 1. So value will start from 1 because of unit step, and because of this ramp which is subtracted from the unit step, the resultant signal will be like this. Now from 1 to 2, let's say 1 to 2, this value is 1. Over here, this value is also 1. So we have subtracted, answer becomes 0. After that, the slope of this line is 0. Slope of this line is 1. Now slope of this line is 1, which will get added. So earlier the slope was this line was -1. One more slope will get added, which is +1. So in the end, 1 minus 1 is 0. Meaning after t equal to 1, we will get a line with a 0 slope and 0 amplitude. Because if you check over here, let's consider this is instant 2, where this line will reach the value 2. So for t equal to 2, unit step is 1. 1 minus 2 will be -1, and -1 will get added with this 1. Answer will be 0. So what will happen after t equal to 1? We will get a line with a 0 amplitude and 0 slope. So overall x of t will be like this. So by using the standard signals and this equation given, we have plotted a x of t. So once x of t is known, getting an even and odd part is easy. So first step for getting even and odd part is we need to time reverse this x of t. We'll get x of minus t like this. And now to get an even part, we need to add x of t and x of minus t and divide by 2 to get an even part. So the signal that we will obtain for even part, through this process, so obviously this signal you will get, which is nothing but x of t plus x of minus t, and we need to divide this by 2 in order to get an even part. So dividing by 2 means just amplitude will change from 1 to 0.5. So it's the even part. For odd part, we need to subtract the signals. So we will get signals like this. We need to get x of t minus x of minus t. So the signals we obtain will be like this. To get a odd part, we need to divide x of t minus x of minus t by 2. So in the end, signal that we obtain of this nature. Which is half x of t minus x of minus t. Just see over here, this signal is symmetrical about a y-axis, hence this is a even signal, whereas if you see this, the signal is passing through the origin, and at the same time time reflection is negative of the original signal, Hence, I can consider this as a odd part. So if I add these two signals, I will get a original signal which is x of t like this. So here we have seen from the equation how to plot x of t, and once x of t is known, how to get even and odd parts. Thank you.